How do functional programmers think about the single responsibility principle? Hi, my name is Eric Normand, and these are my thoughts on functional programming. So the single responsibility principle says that a thing should only have one responsibility. And one way to check if something has more than one responsibility is to say everything it's responsible for, and if you use the word and or but, then maybe it's not a single responsibility. Maybe you have multiple responsibilities in there. And I think that's a good rule of thumb, but it requires you to be pretty astute, because you have to be able to articulate the concerns in that sentence well. What do I mean by that? Well, I could say this object, this class, is responsible for keeping track of the orders coming into the restaurant. Okay, it sounds like one sentence. I didn't use the word and, it's fine. But what does keeping track of mean? Is there some kind of context about like this being a concurrent environment? And so when you start thinking about those things, and these aren't even like operational concerns, right? These are still functionality wise. When you start thinking about those, it becomes clear, like, well, am I talking about durability? Does this have to be stored on disk, right? What about if the power goes out, or the network goes down temporarily? Is there some kind of networking concern that I have to take care of? Is there, like I said before, some kind of concurrency involved? How many systems are giving me orders at the same time? It becomes a pretty it's a pretty big mess of things, and just being able to say it in one sentence, keep track of the orders as they come in, is not clear enough. And I see this happen all the time in the object-oriented world, where they'll think this is a very clear, small responsibility, but actually it's like 100 responsibilities. It's keep track, is deal with the concurrency, right? So you want them to come in a certain order, so you need a queue. You are dealing with persistence. You are persisting to disk. You are dealing with the errors that you have on the network as it flakes out. All of these things are real concerns, and they're responsibilities of the object. And what a language like Clojure does is it will separate out all of those concerns into their own little objects. So, for instance, you have something like an atom in Clojure, which has a single responsibility, which is to maintain a transactional state, right? To make sure that no two threads are writing to it at the same time, right? So you get a consistent transition from one value to the next. And that's all it does. And so I think that this is one of those things that when you come from a different paradigm, from a different language, with a different style of thinking, with a different idea of what a responsibility is, this seems like so tiny and like almost something you weren't even thinking about before. But that is how Clojure gets its power. It's from building these small tools that work, that have such a small responsibility that they can be clearly reused and understood and composed together to define a real solution. So I think that when people talk about single responsibility, they often will make that sentence, but they're not really thinking about all of the responsibilities that a thing might have. And this is one of the problems with reuse in classical object-oriented programming, in Java-style object-oriented programming. Someone will say, it's the same problem, okay? It's the same problem. Someone will say, what is the responsibility of this class to, and it'll be like, to represent a person, right? And it's like, oh, I said it in one sentence without using and, so that must be a thing, right? And the class has like 300 methods, and it's managing all sorts of stuff. And when you look into it, it turns out, well, it can read and write itself to the database. It is, person means a different thing to different departments. So person in the HR department is really an employee, and person in the hiring department is like a candidate, and person in the accounting department is someone that you might have to pay. And so like all of these responsibilities are put together into this one giant object, and really that's not going to be reusable very much. Those methods are going to confuse the different departments because they are using the same words that they're used to, but with different meanings, because different departments have different meanings for them. And it's just going to be like not reusable. If you go smaller though, and I think this was the secret of Smalltalk and why people thought that object-oriented programming would give you something reusable. If you go smaller to something like a tuple, right? Oh, this just keeps two things together. That's its responsibility. It keeps two values. A pair. It could be a 3-tuple or something, and it keeps 3 values. But you have a tuple that keeps 2 values. That's its responsibility. That's it. You have an atom. This makes sure that state changes are transactional. Boom. Awesome. You have something like a hash map. This maintains a mapping from keys to values. And it's just very small responsibilities that are reusable because they're so small and regular, right? That you can rely on them. And so that's how we see this like single responsibility principle. Is that things are not as this rule of thumb of writing a sentence is just not enough. You need to think about the problem and cut it up more down to a smaller, granular level, to where you feel like, yes, this thing is so small, I cannot get it wrong. It has no corner cases because it's so small. It's just it. There's no way that this is wrong. I can rely on this for sure. That's when you know that you've got something, right? Because the level of abstraction you're at, or it all depends on the other tools you have available in your language, right? Like a tuple might be really high level if you're writing in assembly, right? Because you have to deal with memory management, and it's just not right. It's not the right place for that. So it's not something you can just rely on. But if you got all this other stuff like garbage collection and you know, private methods and stuff, you can rely on those things and make something really solid. All right, so I've been kind of rambling on with basically a simple idea, which is like break stuff down more until you feel like this is solid. Then you can put it back together. All right, my name is Eric Normand. Please subscribe. You know, if you're watching this on YouTube, hit subscribe. You can subscribe to the podcast. I also love to hear from my listeners, so I'm at Eric Normand on Twitter, and also you can email me. I'm eric@listcast.com. All right, I'll see you next time.